Hi, this is Edmund, and this is my video walkthrough of the AVL tree. Question 5, where we are going to add the value of 0 to our tree. So to begin with any tree, we start with the node reference of 0, and we look at the parent node here. 0 is less than 5, so we go to the left and come to the node reference 3. 0 is less than 3, so again we go to the left. If our value that we were adding in was greater than the node reference, then we would go to the right. But in this case we just go to the left. 0 is less than 1, so again we go to the left. There is an empty node on the left, well, empty slot for our node to go into the left. So for our tree, the value of 0 would go into the left child node. In a usual binary search tree, this would be the end of things, but for an AVL tree, we have to make sure that it is balanced. What we mean by balanced is that for any node and its left child node and right child node, the height difference has to be no greater than 1. And we'll have a look to see what this means with some examples. Let me just clear out some of the information first of all. This was the original tree that we had, all of this here. This was the original tree, and this was balanced according to AVL. And the reason it's balanced is if we have a look at the node of 6, the left of it is there's no tree, and even if there was, that would be 0. The right of it here is also 0, and this is at level 1. Difference between 0 and 0 is 0, so it satisfies this condition. Similarly with the node reference 8, the left of it is 0, the right of it is 0. Again, difference between them two is 0. Again, satisfies this reference again. Again, this is level 1. Exactly the same with 11 and 13. They're identical. And I'll just put the zeros here as well. Looking at node reference 7, if you look to the left child, the level it is at 1. The right child level it is at 1 as well. Difference between these two is 0. So again, this satisfies this condition again. We can call this level 2 now. Look at the node reference 12. Is identical to 7, 6, and 8, this tree here. So again, identical, this is level 2. If you look to the left, it's at level 1. The right, again level 1. Difference between this one and this one is 0. I'll just tidy this up a bit. We have a look at number 10. To the left of it, the level that the node reference 7 is at 2. To the right of it, the level that node reference 12 is at level 2. The difference between 2 and 2 is 0 as well. Again, satisfies this condition here, and therefore this is fine. And we will call this level. We will call the node reference at level 10. Let me just get rid of these. Level 3. Let's have a look at the left side of the tree here. Again, look at node reference 1. To the left of it, the level is at 0. To the right of it, level is at 0. Difference between 0 and 0 is 0. So this is fine. This is okay. We'll call this level 1. If we look at node reference 3, to the left of it is level 1 because of the 1. To the right of it, there's no child, so this is at level 0. Now the difference between 1 and 0 is 1. this still satisfies the rule that we have, that the left child and the right child cannot have a level difference of more than 1. So this is absolutely fine with level 3. This is absolutely fine. And we will call this, let me just tie this up. This will be level 2 this time. Now we look at the node reference 5. The difference between, if we look at the left child, it's 2. If we look at the right child, it's level 3. Again, difference between these two is just 1. Again, this satisfies this condition again, absolutely fine. And in this case, this is always 1, and it always takes the biggest value out of the left child node and the right child node. In this case, the biggest value is 3. So we do 1 plus 3, which is equal to 4. This is at level 4. Okay, so I'm just going to tidy up a few things first of all, just tidy up all this. So what happens when we add the 0? I might not need to tidy it up. What happens when we add the 0? So what happens is, we add the 0 here. I'm just going to clear this out as well. Okay, and then we start recalculating what the levels are going to be. So, starting from 0, the left, so imagine this is the 0 node that we added. Let me just get rid of this as well. The left child of 0, of the 0 reference node is 0. The right child of the 0 reference node is also 0. This satisfies the condition where the difference cannot be greater than 2, 1. So this is fine, and this is level 1. If we look at node reference 1, the left child is at level 1. The right child is empty, which is at level 0. Again, the difference between 1 and 0 is 1. Still satisfies this condition that we have. So this works as well, and we will call this level 2. Now, when we come to node reference 3, when we look at it, the left node references a level 2, but the right child references nothing, which is a level 0. Now, the difference between 2 and 0 is 2. Now, this does not correspond to the rule that we're saying that the left child and the right child have to have a difference of 1. Therefore, we do have to balance this one here. So, to balance this one, what we are going to do is, let me just tidy this one up again to what the tree looks like. So we know that this is not balanced, and this is where we have to balance things. So what we're going to do is, we are going to rearrange things so that what should happen, what we should see is, the 5 will reference the 1 going forward. The 0 will still reference here on the left. And this time the 3, because 3 is greater than 1, we're going to be moving the node reference to the right of 1. So this is now balanced. So again, we look here. The left and right references of node 0 is 0. The left and right references of node 3 are also 0. So this is at level 1. That's at level 1. The difference between the left node and right node of 1 is also a difference of 0, which satisfies the condition, so this will be 2. The difference between the left and right node of 5 is 2 and 3. Difference is 1, which satisfies the condition. You take the biggest reference between the two, which is 3, so this will become 4 as well. But don't take my word for it. Let's have a look at the visualization tree. Here we're going to add the 0, and I'm using a different visualization tree this time, just to prove that my theory does work. So just going back to the tree that I drew, this is what we should see. The left tree should be, first of all, the reference of 1, with the left node being 0 and right node being 3. The right tree should stay exactly the same as it is. So this is what our final tree should look like, and let's see if it works. If I slow down the speed a bit so we can just see it happen slowly, and then we're going to insert the 0. So this is what it looked like before. So we just insert. You see that 0 is less than 5, less than 3, less than 1. Goes to the left. It is now unbalanced, so we need to rebalance the tree, and there we go, which is exactly the same as what we have right here.